Hey guys, welcome to Derivatives Using Data. In this lesson, we're going to be approximating the derivative using data values. So we don't have a graph, we don't have a function anymore. All we have is data values, and we're going to be able to approximate the derivative at a certain point. So remember that a derivative, what is a derivative? A derivative is a slope. But not just any slope, it's the slope of the tangent line. You could also say the derivative is the instantaneous rate of change. Example number 1. Water is flowing into a tank over a 24-hour period. The amount of water in the tank is modeled by a differentiable function W. 0 to 24 where T is measured in hours and WT is measured in gallons. So we have selected values here of the tank. So water is flowing in the tank. I don't know how the tank looks like. I'm going to say the tank looks like this. And water is flowing into the tank and over a 24-hour period. And here we have the initial amount of water in the tank. So if water was flowing to the tank at 0 hours, there was 150, which means that there was an initial amount of 150 gallons. And then by the end of the 24-hour period, we reached a total of 357 gallons, which means we increased a total number of 257. Okay, so, and every 4 hours in between, we recorded the data, the amount of gallons in the tank. Letter A says, use the data in the table to find W of 8 using appropriate units. Explain the meaning of your answer. Now, here we have a TWT table, very similar to X and Y. This is your X, this is your Y. X is the independent variable, Y is the dependent variable. So Y depends on X. Now, W of 8, well, W of 8, if I go to my table, here's 8, here's W of 8, and it's 221 gallons. So how do I explain this in words? Well, just think logically. Water is flowing into a tank over a 24-hour period. In 8 hours, there was 221 gallons. That's pretty much it. In 8 hours, the tank reached 221 gallons. Okay, letter B. Letter B, we have use the data in the table to find W inverse of 257. Using appropriate units, explain the meaning of your answer. So this -1 power around the W doesn't mean the -1st power, literally. It means the inverse. So remember that in pre-cal, you talked about f of x is equal to y. And the inverse of f of x was f inverse. Okay, now what does f inverse mean? Well, it just means that the domain and the range switched. In other words, the x and y switched. So an equivalent statement to the inverse of f of x is just simply f of y is equal to x. Just switch the variables. That's all it is. That's all you're doing, just swapping the variables. So W inverse of 257. So this is no longer an x. That is not an x anymore. That is a y value. And we want to know what y value corresponds, what x value corresponds to 257. I look at my table and I see 257 corresponds to 12 hours. So it's 12 hours. Okay? Why do we do this? Well, we want to be very fluent in mathematics. We want to be able to understand the relationship of these things that are going on around us. So hours and gallons, we want to be able to distinguish them. So let's go ahead and explain this in words. So we can say that so let's backtrack. So 257 gallons equals 12 hours. So we can say that when the tank reached 257 gallons. The water flowing in the tank took 12 hours. Okay, you guys could probably find a much easier way to explain what I just said, but there's one explanation. As long as you have the gallons corresponding with the hours that we found, you should be fine. Now, the next part is a very important part, part C. Part C says use the data in the table to find an approximation. Note, approximation for W prime of 15. Now, W prime of 15, what does that mean? We all know what the prime means. The prime means derivative. So W prime of 15 means the instant, well, I can say IROC, the instantaneous rate of change at 15 hours. Or I can say the 15th hour. That's probably better. Okay? Show the computations that lead to your answer using appropriate units. Explain the meaning of your answer. Now, this problem is not as hard as you think it is. We don't have a function. There's no way we can find the derivative at exactly 15. And we don't have a graph. There's no way that we can draw a tangent line and approximate its slope. So what we will do is we're going to use the average rate of change to approximate the instantaneous rate of change. So what you want to do, if you're interested in finding the instantaneous rate of change at 15 hours, you have to know that 15 hours, the 15th hour lies in between the 12th hour and the 16th hour. So if I were to take the average of these two, I can get an approximation of the 15th hour. So let's find the average of the 12th and the 16th hour. So we can approximate W prime of 15, since it's not going to be an exact number, or maybe it will, maybe it would be by coincidence, you never know, but we don't know for sure. So we're going to approximate W prime of 15 using the y2 minus y1 over x2 minus x1. So we all know that the y2's comes first. So always begin with the latest hour. So it's 294 gallons, take away 257 gallons, all over their respective hours. 16 minus 12. 294, take away 57. I think that's 37. 37 over 4. And that is a positive, and our units is no longer just gallons. Since we're trying to find the change of the gallons with respect to time, we're going to say gallons per hour. Now, this is not an exact rate of change of what's happening in the tank. It's an approximation. Since all we have is table values, that is the only way we can approximate the derivative at 15. And then it says, using appropriate units, explain the meaning of your answer. We can say the rate at which the water flowing in the tank at the 15th hour is, and then you can even add in there approximately 37 over 4 gallons per hour. You can write that in, you can even express that in decimal. Just make sure you follow the rules. It's 3 decimal places rounded or truncated. And that would be an exemplar response. You could find other ways to reinterpret this if you like, but that's one way to do this. And then it says use the data to find the average rate of change of WT over the time period 4 to 20 hours. So we're trying to find the average rate of change from 4 hours to 20 hours. Okay, so let's use this formula. So it's going to be 20 minus 4 for sure, and it's going to be W of 20 minus W of 4. Well, I need to go back to the table because I don't know what W of 20 is. W of 20 is 327, W4 is 184. 327, 184 over 20 minus 4. The bottom is 16. The top, I think, is 7. No. 3. And then 14. Let's see. I'm doing calculus videos and I can't even subtract. 3 and then 143. Yeah. Okay. 3, 4, 7. Yes. Okay. Good. 16 over 143 over 16, and then it's, since we're taking the rate of change, so we're taking the change of water with respect to time, so we have to say it's gallons per hour. And then letter E, for 0 to 24, must there be a time where the tank contains 265 gallons of water? Justify your answer. Now, anytime you see a problem like this, where it says must there be a time where so and so gallons was in this hour or this period, we're talking about IVT. IVT is that airplane theorem that I told you guys. If the airplane falls all the way down to the ground, could there have been a time which the airplane's altitude was 666 feet? Well, yes, there was, because the airplane's trajectory is continuous. In other words, the amount of water changing, the amount of water in the tank as it's increasing in water level is also continuous. You can't skip from 1 gallon to the next instantly, right? It's continuous. So what was the number again? It was 265 gallons, and it seems like 265 gallons should be somewhere here in between this interval. And we say, well, of course, right? There must be a time. How do we answer this? We have to answer it using logic. So let's start up with the first value. At the 12th hour, there was 257 gallons. So we're going to say yes, because W of 12 well, let's come back to the top over here. Notice that it says differentiable function. W is a differentiable function. And in the last lesson, and even I think the lesson before, we said that if a function's differentiable, what does it imply? It implies that it's continuous, but not the other way around. Continuity does not imply differentiability. Only differentiability implies continuity. So we're going to say because W is continuous, and this statement right here is what's going to give you the point, not the logic behind this. The logic is knowing your calculus, knowing that differentiability implies continuity. So yes, because W is continuous, and now you apply your rationale. W12 is equal to I'll go back up in a bit right now. W12 is equal to something, and W16 is equal to something else. So let's go back up here. 257 and 294. 257 and 294. There must exist a time. Or we can say there must exist a t, a time equals, I don't know, c, such that W of C is equal to 265. It must be obvious that in between there. Could could the water have been could the water have reached 265 gallons in any other time? Well, maybe, right? It depends, right? But all we know that the water is flowing into the tank, and we're assuming that it's not stopping. So there must be at least one instance in between the 12th hour and the 16th hour in which the water level was 265 gallons.